So we talked about U-substitution in the past, and I think we did fairly well on it, but I remember there being some confusion about, like, what's U? How do we know what du is? Why does du go away? So I think this is probably one of those sections that's good to review in the sense of AP, just because it gives us that basis of getting those questions answered again and being able to go back over it. So we're going to look at question one, and that is the integral of 3x squared times x cubed plus 1 to the fifth dx. All right. And what we always want to remember is if we're integrating, we can integrate 3x squared, but we can't really integrate this unless we have some type of substitution for it. So this is where U-substitution comes into play. I'm going to change my x cubed plus 1 into a u, right? And then my du, if I took the derivative of that, would be 3x squared dx. That way I can rewrite the problem. And when I rewrite the problem, I now have the integral of u to the fifth du, because I'm taking my x cubed plus 1, making that u to the fifth, and then du is 3x squared dx. Once I get to this point, I just integrate, which means I'm going to add 1 and then put that same value down in the denominator. So we get u to the sixth over 6, and then plus c, because it's an indefinite integral. And once you get to this point, you substitute back in. So you're like, oh, hey, I remember what u is. U was x cubed plus 1. My u is now to the 6th power, so that's to the 6th. It's over 6 plus c, and that's your answer. How do we feel about that?
Good.
Okay. I remember there were some questions about, like, what happens to du and that kind of stuff, so I wanted to make sure we went back over it. Okay, so let's talk about another one. Let's talk about numero dos. And numero dos says if we have the integral of x and then the square root of 4 minus x squared dx, we're going to do the same thing. Except it might be worth looking at this as the integral of x times 4 minus x squared to the 1/2 power dx. It's strictly up to you. It doesn't really matter to me how you write that. But that might be worth it just because in a few minutes that 1/2 will be helpful. All right, again, we're going to say, okay, our u, in this case, is what's under the square root or in parentheses. So that's going to be 4 minus x squared. And our du would be negative 2x dx. I don't have a 2x or a negative 2x, so how do I get a negative 2x on the inside? Do we remember?
Multiply it by -2.
All right, I'd have to out here put a negative 1/2, right? Which would make this a negative 2. Do we remember that? Because I'm basically need to multiply by a positive 1, right? And negative 2 over 2 would be, negative 2 over negative 2 would be 1. Yes, no, maybe so.
Yeah.
Mm-hmm.
Okay, so we're okay with that. All right, so that means when I rewrite this, let me go back to purple. I have negative 1/2, and I'm going to integrate. Well, I have my u. It is to the 1/2 power, so u to the 1/2. And my du is negative 2x dx. Negative 2x dx, so I got my du. And then I go back and did what I did in the previous problem. I'm going to add 1, which I add a 2 over 2, so this becomes negative 1/2. And then I'm going to put a parentheses. This becomes u to the 3 over 2 over 3 over 2 plus c. Hey, what happens here? This is going to flip up, right? If I want to bring it to the numerator, because it's a fraction, because u over 1 over a fraction.
Yes.
Okay. this would flip up. So in other words, it becomes 2/3. Hey, what's negative 1/2 times 2/3?
Yes.
Negative 1/3. All right. U to the 3/2 plus C. So then you come back and you substitute your U back in. So you get negative 1/3. And then you have your U, which was 4 minus x squared. And that's a 3/2 power plus C. All right, so that's very similar to what you did before with U-substitution. And I have two other problems that are similar that I'm going to let you all do for like homework and we can talk about on Thursday. Sorry, my days are mixed up.
Wait, can you explain the negative 1/2 in front of the integral real fast again?
Yeah. If I want this, so when I have my U, when I take the derivative of it, I get a negative 2x here, right? In the problem, there's an x, not a negative 2, just an x. In order for me to get that negative 2 on the inside, I have to do a negative 1/2 out here, which brings a negative 2 in here, because what I'm really doing is I'm multiplying by negative 2 over negative 2. I've just split up where each piece goes.
Okay.
So that's it. That's where it came from.
Okay.